A very warm welcome to everyone. In this video, we are going to learn about linear regression. So what is linear regression? It provides a linear relationship between an independent variable and a dependent variable to predict the outcome of future events. So before we dive deep into the concept, first let us understand what is an independent variable and a dependent variable. So to answer that question, first let us take one example. Suppose we want to know the annual sales of a company. Okay, we want to find out the annual sales of a company. So annual sales of a company is the independent variable, is the dependent variable. Now this annual sales depend on what factors? So for example, the annual sale of a company, let it depend on the say profit, loss, number of customers, number of employees, etc. So these factors will be the independent variables and the dependent variable will be the annual sale. Okay, so the concept is clear, what is dependent and what is independent. Now if we want to establish a relationship between the dependent variable and the independent variable, then the best way to do so is to apply regression analysis. And the statistical method, linear regression is a statistical method that is used in data science and machine learning for predictive purpose. Predictive purpose means if today or in the historical data, if these are the data we have, then what is the outcome that will be in future. Okay, so it is a supervised learning algorithm that simulates a mathematical relationship between variables and make predictions for continuous or numeric variables. Supervised learning algorithm means, if suppose we have an example, consider the same example, that is the profit, loss, then number of employees, then the number of customers, all these data will be given, and for this particular data what will be the output will also be given. So based on that, is the output is label, we already have the value. So using this data, if we make the prediction, then this is known as supervised learning algorithm, that is we already have the labeled data. Okay, so what it aims is to find the best fitting straight line or hyperplane in higher dimensions that describes the linear relationships between the variables. So for that, let us see this diagram. So here y represents the independent variables and x represents the dependent variables. So these are the different values, data points. Okay, so we try to find a line that best fits the model. Okay, and it is in linear in nature. Linear in nature means for lower value, if we get this one, so as the value of y increases, the dependent variable value also keeps on increasing. So this is the linear relationship. Now linear regressions are of two types. One is simple linear regression and another one is multiple linear regression. Now what do we mean by simple linear regression? If there is only one independent variable, then it is simple linear regression. Suppose we want to find out the sales or annual sales of a company, and it is dependent, say suppose on the total number of customers. Okay, so only one independent variable, so then we go for simple linear regression. So this is the formula. So here beta naught and beta 1, these are known as the coefficients, regression coefficients, and epsilon is the error. Okay, so y is the dependent variable, x is the independent variable, that is in our example x represents the number of customers. Okay, now beta naught is the intercept. Intercept means the value of y when x is 0. So when the number of customers is 0, what is the value of y? And beta 1 is the coefficient associated with x, that is, it is the, in simple terms, it is the slope. Okay, so this is the formula for simple linear regression. Now for multiple linear regression, we simply modify the formula like this. Okay, so here this is the intercept, that is when the value of x is 0, what is the value of y, and here this represents x1 x2 dot dot dot, this represents the factors. So suppose x1 represents the, in our example, let x1 represent the number of customers, x2 represent the profit. So like that we can have n number of factors, so the formula will change accordingly. Okay, now let me explain what is the significance of this beta 1 beta 2, that is the slope. Okay, so consider this example. Suppose here for assumptions we are not bothered about what is y, b0 and x1 x2, just concentrate on the values of beta 1 beta 2 beta 3 and beta 4. So what does these values represents? These values represents the impact of these factors in predicting y. So if we see this equations, x3 has the highest value for beta, right? So we can say that this factor, whatever is the factor x3, it is going to have the maximum impact on predicting y. It is of most importance. So first for example, suppose you want to find out the result of your exam, and suppose x3 represents your marks, then suppose x4 represents your roll number. So we can see that the output, my result is not that much dependent on my roll number. So here we have given a low value of beta, but the marks obtained, it is of very much importance, so the coefficient is very high in this case. So it is clear, I hope, what does this beta 1 beta 2 beta 3 beta 4 means. Okay, now question comes, who is going to give these values of beta naught, beta 1 beta 2 beta 3? So when we will do the programming, the model itself will learn the values. So depending on the data, that is the input or data set that you will give, the machine will train itself, the model will train itself to understand which feature is going to have the highest impact on predicting the value of y, and accordingly the model will give the values. Now let us see how mathematically we can solve linear regression. So this is an example given. So we have study hours and we have exam score. That is we want to predict the student's exam scores. So we want to predict the student exam score. So y is the dependent variable and x is the independent variable. So obviously it belongs to simple linear regression. Now we will simply use the formula. So this is the formula here. So here we need to calculate the value of beta naught and beta 1. So in linear regression we already have the formula for that. So the formula for the slope, that is beta 1, is summation of xi 1 to n xi minus x dash yi minus y dash divided by summation of I equal to 1 to n xi minus x dash whole square. So here x dash and y dash represents the mean. So we have already calculated. So how to solve this? So first we will calculate the mean, x dash for the number study hours and y mean for the exam scores. So after that we will put it in this formula. So when we put the values, we get this beta 1 value, which is minus 4 by 13. Now we will try to find out the intercept value. Then the formula for intercept is y mean minus beta 1 into x mean. We already have the values of this beta 1 also we calculated here. So we will simply put the values to get this one. So now we have the intercept value also. So now simply since we have the coefficients, we will simply put it in the equation. So exam score, that is we need to find out exam score. If you see, it is represented by y. So we need to find y. So y will be equal to what? Exam score equal to intercept minus slope into study hours. So simply put it here, that is y equal to beta naught plus beta 1 into x. That's what we have done. So we have put the values and found out the scores, okay, exam scores. So this is how you're going to solve a linear regression equation. So this is the final regression equation that we got. So based on the study hours, you can predict the exam score. So what are the applications of linear regression? So in economics, it can be used for modeling the relationship between variables like income and expenditure. Then for finance, we can predict stock prices. In medicine, predicting patient outcomes based on various factors. So these are some of the applications given. There are many more applications available. So now, after going through the since we have gone through the theory part, now we will see how we can create this linear regression model using Python. So let's go to Jupyter. So this is the program using Python to find out to perform linear regression. So first of all, we will import the libraries. So we have imported NumPy, then we have imported pandas, then using sklearn we have imported train, test, split. Then we will be using the linear regression model, so we have imported this one also. And we have imported some metrics also, that is to find out the accuracy of the model, mean square error and R2 score. So suppose this is the sample data that we have, study hours, and these are the exam scores. So for the number of study hours 2, exam score is 60, for 3 65, like that, okay. So total we have this much of data. Now we are going to so these datas are given in this form, so we need to convert it to a data frame. So we will write df equal to, using pandas, pd.dataframe data. So we are going to put this data here and we are going to convert it to a data frame, okay. So now we need to split this data. Now this data frame will contain x and y values. Now x is the independent variable and y is the dependent variable. So we are going to split the data into independent and dependent variables using x df of study hours and y equal to df of exam score. Now this whole data set we need to split it, okay. That is, some part of the data will be used for training and another part will be used for testing. So for testing we are going to use 20%, so I am writing 0.2, okay. So so this is the way we were going to write. So train, test, split, this is a method that is already available in Jupyter, that is already available in sklearn model selection, okay. So in this, by writing this code, we are going to split it data. For training set we will keep 80% of the data and 20% will be used for testing purpose, okay. Now we are going to call the function linear regression model and we will put it here in the model. Now we are going to fit this model in the training data and for x train and y train. X train represents, what does x train represents? It represents the exam score. Exam score means the what we want to predict, and y train is the independent data, okay. So after fitting this model we are going to do the predictions. So y pred equal to model dot predict. So based on this x test we are going to predict the y, okay. So after this we are going to display the intercept. So we have written the intercept model. We just need to call model dot intercept. It will display the intercept value, and model dot coefficient, which will display the coefficient or slope value. And if we want to find out the metrics, that is how our model is performing, using mean square error, that is the mean of the square of the errors, whatever errors we are getting, we need to call the function mean squared error, pass y test and y pred values, and then if you want to find the R square value, you need to call R2 score, y test, y pred. So these are the, for intercept we are getting the value 49.9, and for coefficient 5, and mean square error is 0, and R square is 1. So that is how you can perform linear regression. So if you like the video, please do like and subscribe. Thank you everyone.